Where's my ruler? Here we go. Tell me about vertical asymptotes and holes. Or don't tell me about vertical asymptotes and holes. Factor and then? Got it. What do you want to factor?
The bottom.
Ooh, you're on the ball today. Okay, so what's the conclusion about the first binomial? Conclusion about the second binomial? Okay, so if one cancels and one doesn't, no big deal. One's a whole, one's a vertical asymptote. Tell me about horizontal or oblique asymptotes. Well, before we get to that step, we analyze the degree. What's the degree on the top? And the degree on the bottom? And which scenario is that, 1, 2, or 3? And then we go, oh, shoot, it's number 3. Okay, how do we do that weird division thing?
You draw lines and put numbers on.
Yes, so upside down division sign. Why is it degree over degree plus 1? Okay, what do we put inside the weird division thing? Coefficients, and so I always like to just remind myself the first column is the x squared, second column is the x, and the third one is the constant. And is that of the top or of the bottom? The bottom, because that's where the x squared is. So what's the coefficient of the x squared? Coefficient of the x? Coefficient, or constant? How do we use the top? Yeah, how do we use the numerator to get the number out here? We set it equal to 0, right? So you can do this in your head if you want to. And then x equals -3. Okay, so let's just put some notes for the wordy people. Okay, where did these come from? Could we use some math words? Okay, so something with the denominator. Specifically, what are 1, 0, and -9? Coefficient slash constant. Where did the -3 come from? So the numerator equal to 0. First number drops straight down. This becomes the number in the first column. -3 times 1. Add. -3 times -3. Add. Okay, how does that give us an oblique asymptote? The 1 is the m, and the -3 is the b, and what about the 0? Don't care. So our oblique asymptote is y equals x minus 3. No, it's always m and b is what happens, turns out. Numerator equal to 0. Okay, intercepts. How do we calculate an x-intercept? Y equal to 0. Thanks, Noah. Take a look at this. Look at the hole. Look at the x-intercept. What does that tell us?
That there is no x-intercept.
That it's a hole on the graph. So when we go to graph these tomorrow, we'll actually end up putting a hole right on the x-intercept. Y-intercept, x equal to 0. So if you can do this in your head, you don't need to show it. If you want to write it out, great too. Top's going to be 3, bottom's going to be -9. Total of? Coordinate? I think you can do the last one. Give you a couple minutes and we'll discuss. Factoring. Somebody want to give me the top? Ooh, that was almost in stereo. And the bottom? Thank you. And the bottom? Confirm. Okay, conclusion about the first one? Conclusion about the second? So don't think just because there's two, one has to cancel. And that's what you're going to want to do, because when we did rational expressions last year, we were like factor and cancel, and one always seemed to go. If it doesn't cancel, it doesn't cancel. So don't try to make it cancel just for the sake of canceling. Who had both of those? Okay, horizontal asymptote. Degree over degree, and we're like, yeah, what does degree over degree mean? So just the coefficients, no factoring involved, none of that stupid division. Y cannot equal 1. Who had that? X-intercept. Okay, so y equal to 0, what's going to happen with the bottom? So we can jump right to the factored form, which would be the smartest, because it's already factored, it's in the right form, we're happy. X equals, and x equals. Okay. And again, I like to give them as points just so I don't mix up that they're asymptotes or holes or anything else. You don't have to give them as coordinate points. Y-intercept. This one's actually the easiest to go back to the original, because what's going to happen with all the x's? They're going to all be 0, so what's going to be left on the top and on the bottom? Bless you. And when we reduce, who had all of that correct? Awesome. Questions? Anything you're not sure of? Mm-hmm. So we have the 3 situations from yesterday, the degree plus 1 over degree, degree over degree, degree over degree plus 1. When it's the middle or the second one, which is degree over degree, we take the 2 leading coefficients and divide them. So 1 divided by 1, 1. That's where it comes from. For my right-brained people, I have a flow chart of exactly what we just did. There's one for you here, Noah. Right. So this is everything we just did, and it's what we're going to use tomorrow when we do the graphing. So you start with whatever your function is, vertical asymptotes first, factor everything, look at the denominator. If it cancels, it's a whole. If it doesn't cancel, it's a vertical asymptote. Going to the right, the number of vertical asymptotes will tell you that shape. So from yesterday, if there's none, it's speed bump. 1 is a variation of volcano, and a variation of said phase for 2. From there we go to our horizontal asymptote. First two possibilities are for horizontal, so degree over degree plus 1 is always our happiest. Y equal to 0, degree over degree is the leading coefficients. So if you're not sure later what A and B represent, you might just want to jot down in words, it's the leading coefficients. If it's not those, then it's our oblique asymptote, and we use synthetic division. And then it says see next page because this was going to be the notes, but then I took it out to have it as a separate page. So the next page is your note page. Okay, so if that works better for your brain, use that. Again, we're going to come back to that tomorrow when we actually do the graphing. Homework today is going to be two things. First is just practicing what we did in this example. So just practicing getting the vertical asymptotes, the horizontal. Second thing is going to be example number 4. We did rational equations algebraically last year. That was in Unit 7. So that's when we factor everything, get a common denominator, blah, blah, blah. Now we're just doing graphically. There are two methods. What are the two methods? And please don't say method 1 and method 2. What are the two methods? So y1 and y2. And the other method? All into one side. Which one do you want to do? Okay. You walk me through it. Blah. Wait, do we need to check the mode? What kind of questions does the mode affect? Anything with a trig in it. That's the only thing the mode affects. Is there a trig in this one? No, so we didn't need to check the mode. It doesn't matter. Okay, y2, how do I punch all this stuff in? There's a lot. I'm scared. Oh, Kate. Whew, that wasn't so bad. What is that? What is that? Well, let's talk about the rational part of the graph. We've already looked at the 3 different types, so ignore the line for now. What type is this? What do you see? It's a variation of volcano with the piece on the top in quadrant 2 and a piece down here in quadrant 4. What's this kind of jagged line going up the middle? Yeah, calculator has a hard time drawing asymptotes. We've talked about this before because it's hard to code a vertical line because a vertical line has an undefined slope. And how do you code something undefined? So you just need to realize that jaggedy line is an asymptote. And again, it's hit and miss. Sometimes the calculator won't even put the asymptote. Yeah, sometimes it does, sometimes it doesn't. It's really hit and miss with the asymptotes. So step number 1, to get our first point, draw it. So just a little sketch of what you see. We use rulers because we're civilized people. Okay, so there's a rough sketch. I'm not putting any specific values down. It's not exact. It's a rough sketch of what you see. Okay. Note that even if your calculator didn't draw the asymptote, you need to draw it because you know better than your calculator and you know that it's there with the rational graph. How do we get the second point for the question? And what are we trying to find in this? Intersects. 2 of them for this question. How do we get the third mark for the question? Okay, how do we do it? You kind of forgot you were telling me what to do. And what do we care about, the x or the y? We only care about the x. Was there any rounding instructions in the question? Okay. Who has a different answer? Oh, nobody does. Sometimes yours might jump to the other one, just depends where your cursor ended up. So mine went to the very first one, you might have gone to the second one. Okay, so repeat second function calc, number 5. Okay, how do I get it to give me the other one? Just move closer to it. Okay, so it doesn't have to be left or right specifically, just if you're close to it, calculator gets it. And to 1 decimal place. Okay, so exactly what we did with trig graphs when we did them on their calc, exactly what we did yesterday with rational or radical graphs, just a calc question. Questions?